Yeah, good afternoon, class. This is Daddy Cause, or Cosmas Dollar, your chemistry teacher. We'll be continuing from our our discussion about salt. So here this afternoon we'll be talking about solubility rule. You know, the rule that you can use to predict whether a particular salt will dissolve in water or will not dissolve in water. You know, you need this rule. Very, very important. When you understand this rule, even by closing your eyes, if you see any compound in your dream, you will know that that compound can dissolve or will not dissolve just by this simple solubility rule. It is your power as a chemistry student to understand the solubility rule because it's going to help you in a lot of ways. For example, you need to understand solubility rule for you to know the method that is appropriate to prepare a particular salt. That tells you the solubility, the importance of that rule. If you don't know if a salt is soluble or not, you will not be able to know what method will you use to prepare it. Then, even recovering a salt from solution, the knowledge of this solubility rule will also help you very, very well. Now, let us start. What is this rule all about? For number one, all sodium, potassium, and ammonium salts are soluble in water. You can see, we call them sparse salts. Sodium, potassium, and ammonium salts. All of them are soluble in water. No exception. No exception. So all sparse salts are soluble. Any salt that contains sodium, that contains potassium or ammonium, that salt will be soluble. So if you see Na inside the salt, that salt is soluble. Or if they tell you the name of a salt and there is sodium inside, that salt will be soluble. So any salt that contains sodium, potassium, or ammonium, we call them sparse salts. Though it's just my own way of mnemonizing the thing to make you understand it very well. I just call them sparse salts. So all sparse salts are soluble. All sparse salts are soluble. Take note of that. Very, very important. Now, the second one is the triazonitrate 5 salt. Please, that VI is supposed to be V. Is triazonitrate 5 salt. So all salt that contains NO3, all of them are soluble. All salt that contains NO3, all of them are soluble. All nitrate salts are soluble. Whatever might be at the back, copper, gold, whatever. Once the salt contains NO3, the salt will be soluble. All nitrate salts are soluble, and there is no exception. No exception. All of them are soluble. I hope that's clear. Now for number 3 now, that's acetate salt. Acetate. This acetate. All acetate salts. Sorry about that. All acetate salts are soluble. All of them. So I'm in number 3 now. All acetate salts are soluble. No exception. Lead acetate, silver acetate, sodium acetate, potassium acetate, magnesium acetate. Once the salt is an acetate salt, the salt will be soluble. You are not familiar with acetate salt. They are organic chemistry salts. When you get there, you understand. So all of them are also soluble. There's no exception. They dissolve in water without any exceptions. So we are seeing 3 types of salts that whenever you see them in your dream or in real life, once they wake you up, okay, salt is soluble or not, you already know that this salt is soluble. Number 1, sparse salt, that is sodium, potassium, ammonium salt. Number 2, nitrate salt. All salt that contains NO3, they are soluble. Then number 3, acetate salt. Number 3, acetate salt. So I hope you understand that now. Now let's now move to some other salts that not all of them are soluble, but most of them are soluble. Number 4, that's chloride salt. Most chloride salt are soluble. Don't let me say all because there are exceptions. But when you see a chloride salt, first of all, assume they are soluble because most of them will be soluble, except the chloride salt contains lead or contains silver. So when you see chloride salt, automatically assumed it will be soluble until you check it and you see Pb at the back. So if the salt is lead to chloride, then the salt will not be soluble. And of course, if you heat the water very well and the water is very hot, the salt can dissolve. That lead to chloride is soluble in hot water. But if the water becomes cold, then it will no longer dissolve again. So it will precipitate out. You don't even know of precipitate. We have done that before. So that is about chloride. Lead chloride is soluble only in hot water. Then silver chloride is not soluble at all. So of the 2 chloride salts that are insoluble, lead 2 chloride is insoluble and silver chloride is insoluble. But take note, lead 2 chloride can dissolve when the water becomes hot. Apart from these 2 compounds, for your level, assume that all the other compounds of chlorine, that is all compound that contain Cl, assume they will be soluble. It's not hard, isn't it? All sparse salt are soluble, all nitrate salt are soluble, all acetate salt are soluble. Now, most chloride salts are soluble, with the exception of PbCl2 and AgCl. So when you say chloride salt, first of all, assume it will be soluble, but check the metal at the back of the chlorine. If the metal is lead, then it will not be soluble. If the metal is silver, it will not be soluble. So those 2 chloride salts are the insoluble chloride salts that we have for your level. There are some advanced chloride salts that are insoluble, but you don't need to bother your brain about that for now. When your brain becomes bigger and you become more matured, then I'll be exposing you to those chlorides. Now, sulfate salt. So we are number 5 now. Sulfate salt, you can see tetraoxosulfate 6 salts. Most sulfate salts are also soluble. It's just like chloride. Most sulfate salts are also soluble, but with few exceptions that you are supposed to know. Number 1, calcium sulfate. This calcium sulfate is, it's not that it's not soluble, it's just sparingly soluble. That is, very only minute part will dissolve in water. It's just like throwing what do you call it now? Let me use chalk, for example. Throwing chalk inside water, a bunch of chalk. So only few of it will get wet in the beginning. The bag will get wet. So, but as time goes on, the thing will get. But normal, that's just sparingly. But calcium sulfate is just like that. A little amount will dissolve, but you still see the chunk of the salt, plenty of the salt, undissolved. So we call that sparingly. Sparingly means very, very little. Very, very little. So calcium sulfate dissolves sparingly in water, but not very soluble in water. Take note. This calcium sulfate salt is a very important salt to us in chemistry because it's the one that causes permanent hardness of water. You know that some water can be hard. You have not seen hard water before. When we get there, you will see that some water can be hard. So when calcium sulfate inside the water will be hard because part of it can enter inside the water and dissolve in water. So it's sparingly soluble. Now let's come to lead sulfate. If the sulfate salt contains lead, the salt will not dissolve. Did you observe that for chloride and for sulfate, whenever they contain lead, they don't normally dissolve? You can see that lead 2 chloride doesn't dissolve, lead 2 sulfate also doesn't dissolve. So whenever chloride salt or sulfate salt contains lead, the salt doesn't dissolve in water. So there are exceptions. Now finally, barium sulfate. Barium sulfate does not dissolve in water also. So we have 3 exceptions to the solubility of sulfate ion, of a sulfate salt. Calcium sulfate, that one is sparingly soluble. Lead sulfate, that one is insoluble at all, alongside barium sulfate. So I hope you understand it now very, very well. So what you just need to note is that all chloride, most chloride and most sulfate are soluble, except you see lead. Once you see lead at the back of a sulfate or chloride salt, is insoluble. Now for chloride, silver chloride is insoluble. Is that okay? Now for sulfates, calcium sulfate is insoluble, lead sulfate is insoluble, then barium sulfate is insoluble. There's something that I want you to also know. There's one sulfate salt that doesn't dissolve also. The sulfate salt is called silver sulfate. Just like we have silver chloride that is not soluble, silver sulfate is also not soluble. Ag2SO4. That silver sulfate is also not soluble. It's not soluble also. So you see, silver chloride is not soluble, silver sulfate is not soluble, lead chloride is not soluble, lead sulfate is not soluble. Take note of that. So the only differences in the solubility from sulfate and chloride that are exception now is calcium sulfate. Calcium chloride is soluble, but calcium sulfate is sparingly soluble. So once you see lead or you see silver at the back of a chloride salt or at the back of a sulfate salt, that compound will not dissolve in water. It's an insoluble compound. Please don't forget that. If you need to memorize, but I'll be able to arrange it such a way that it will be easier for you to comprehend very, very well. So we are done with the hardest part, which is chloride and sulfate that have exceptions. The remaining ones that we'll be treating now, they are insoluble. They can't dissolve at all. They won't dissolve. They will not dissolve at all, except they are spar salt, except they contain sodium, potassium, and ammonium. And let us start. The first of them that are insoluble, carbonate. All carbonate salts, my brother, all carbonate salts are insoluble in water. All carbonate salt, except it's a spar salt. That is, except the sodium carbonate, potassium carbonate, or ammonium carbonate, except the salt is a spar salt. All carbonate salts are insoluble. Only the spar salt. Is that not easy? What the salt is a carbonate salt? This one cannot dissolve, Jerry, except you now see that there's sodium there. All sodium salts are soluble, so you now get that. So all carbonate salts are insoluble, except those salts are spar salts. So you get that like that. The same rule that applies to carbonate also applies to sulfate. Look at it. All sulfate salts are also insoluble. And it pays us because there is a sulfate salt inside our teeth. Calcium phosphate rather. Assuming phosphate salt are soluble, you'll not be able to drink water. All your teeth will just dissolve away. And you not like that because of the Sunday chicken I normally eat. So that's why it is good that some salts are not soluble. Imagine if calcium carbonate is soluble. You know that calcium carbonate is limestone that we use for building house. Imagine if it's soluble in water. Anytime there is rain, your house will just dissolve, as if it's a cube of sugar, and you will not like that, isn't it? So you can see the importance of some salt being insoluble. Calcium phosphate in our teeth is insoluble, so it's very good that it remains there. Also limestone, calcium carbonate. So all phosphate salts, all tetraoxophosphate 5 salts are insoluble except it's a spar salt. Except it's a spar salt. Except it's a spar salt. So all tetraoxophosphate 5 salts are insoluble except it's a spar salt. Take note of that. It will be very good for your health when you remember it. So finally, this number 8, they are not actually okay. They are not all salts. Actually, oxide is not a salt. Oxide is a base. If it's a for what do you call it now? For metals, the oxides of metals are bases. Also hydroxides, they are also bases. So, but I just want you to know that they are also not soluble. They are also not soluble except they are spar salts. Except they are spar salts. So all sulfide, oxide of metals, hydroxides, also they are insoluble compounds except they are spar salts. The only exception that I want you to note about hydroxide is that hydroxide is sparingly soluble. Calcium hydroxide, not all the hydroxide though. Calcium hydroxide, calcium hydroxide, they are insoluble. They are sparingly soluble, but the rest are not soluble. So sulfide salt, oxide salts of metals, hydroxide compounds, they are insoluble except they are spar compound. So I hope you understand that and you get it very well. So that is the solubility rule. Solubility rule. That's not hard. Make sure that you learn it, you know it. When you know it, it's very good for your health. You'll be very healthy. You'll not be visiting health bay when you understand all these things during your exam. So let's see some examples that will make our life to be okay. Let's see this checkpoint 5. I said you use solubility rule to determine whether the following salts are soluble or not soluble. Now, see the first one there, KNO3. See KNO3. Will it be soluble or not? Of course, it will be soluble in 2 parts. It contains potassium. All spar salts are soluble, isn't it? Then apart from that, it also contains nitrate, NO3. So since all nitrate salts are soluble, it will also be soluble. So there are two ways by which this salt can become soluble. That KNO3 is a spar salt. It's also a nitrate salt. So it's a very soluble salt. Just note that when it contains one particular radical that can dissolve, it will dissolve altogether. Now let's see number 2 now. Number 2 is calcium chloride. Calcium chloride. Now see calcium chloride. If you want to check if it's soluble or not, you go under calcium, under chloride rather. Under chloride, you see that all chloride salts are soluble, with the exception of lead 2 chloride and silver chloride. Now I told you that whenever you see a chloride salt, first of all assume they are soluble until you now check the back. So if you now check the back of that salt and the metal that is there is not lead and it's not silver, then you know that salt is soluble, because those lead 2 chloride and silver chloride, they are the exception to the salt solubility rule of the salt. So since calcium is not silver and is not lead, so its chloride is very soluble. So we have seen that calcium chloride is soluble. Calcium chloride is soluble. Now let's see number 3. Number 3 is copper chalcocarbonate 4. copper 2, that's CuCO3, copper 2 triazocarbonate 4. Now, will it be soluble or not? You check this anion. It's a carbonate salt. It's a carbonate salt. Now, you ask yourself this question: are carbonate salts soluble? If you don't know, you go and visit the solubility rule. If you check the solubility rule, all carbonate salts are insoluble except their sparse salts. So, and copper is not sodium, it's not potassium, it's not ammonium, so it's not a spar compound. So copper carbonate is insoluble, and in fact it's very, very insoluble. So it's an insoluble compound. It's a green powder. It's not soluble. Let me give you one hint. When you're in the laboratory and you see any chemical that looks like a powder, that compound will not be soluble. Most times they will not be soluble. But the one that looks like sugar, that looks like salt, like common salt, the one that is crystalline, they are always soluble. It's just a trick, It's good for you to know that. Now, let's see silver chloride. Now, I've told you already that whenever you see chloride, first of all, assume the compound will be soluble, except you now check the back, whether there is no silver at the back or there's no lead at the back. So if silver is at the back, then it will not be soluble. Or if lead is at the back, it's not soluble. So this one now is a silver chloride. So the chloride of silver is insoluble. So that is why we know that it's not soluble. So you can do the rest. Number 5 is ammonium chloride. Do you think it will be soluble? Why will it be soluble? After that, what you assume about chloride. And of course, ammonium chloride, ammonium salt. You know what happened to ammonium salt. Are they always soluble or not? Now see PbSO4. Number 6 is PbSO4. Are they soluble? Is lead sulfate soluble? First of all, check all sulfates. Assume that all sulfates are soluble, except you now see some metals at the back that are not good for their health. You know those metals. I won't tell you the answer. Now zinc carbonate. You've seen you've seen that it's a carbonate salt. Now what's happened to solubility of carbonate salt? Are all carbonate soluble or they are insoluble? Go and check the solubility rule. Then you will know it. Now let's see number 8, aluminium phosphate. That's aluminium tetraoxophosphate 5. Now go and check. It is a phosphate salt. So are all phosphate salts soluble? If not, are they insoluble? So you go and check. Number 9 is a sulfate salt. Now check. Sulfate salt, are they all soluble? Are they not all soluble? You check sulfate salts. Are they all soluble or they are not all soluble? So if they are not soluble, what are the exceptions? Is calcium part of the exception? So you check by yourself. Then sodium carbonate is a carbonate salt. So you go and check under carbonate. Are carbonates are soluble? Or it has sodium at the back. Would that one make it to dissolve or not? So that's how you check and you confirm whether salts are soluble or not. So let me see your answers to this. If just go through it, anyone you don't understand whether it's soluble or not, let me know. You can voice note me on WhatsApp. So I will answer your question speedily and readily. So that is that about solubility rule. So by now, I think and I know that you will be able to know if any salt is soluble or not soluble. That's how you become chemist. That's how you can have confidence whenever you are working in the laboratory that I'm now a chemist. So that is that about that. Now, let's go to preparation of salt. How do we prepare salt? How are salts prepared? You can see from this place now, there are 5 different ways by which salt can be prepared. You know all those formulas that I gave to you: acid plus base, salt and water, acid plus metal, salt and nitrogen, acid plus carbonate, salt, water and carbon dioxide. Don't forget that, you remember that. acid plus trisulfate 4 salts